Welcome to our last day, our last session on Agent Bootcamp. I want to first welcome you all to our session, and I also want to make sure that you all can hear me and see me. So can I please get just send me a yes or no if you guys can see me or not. All right, awesome. So what we'll do is that we'll get started with the overview today of what we're gonna cover. I'm gonna go ahead and share my screen. All right. Hopefully everyone can see my screen. Today is a great day. We'll be covering very interesting topics. One of my favorite things, we're going to talk about agent to agent ecosystem, which is going to be a major role on or major discussion point on how agents go from being independent on what we discussed yesterday to building something which is all multiple agents working hand in hand. So without further ado, let's get into it. So first off, welcome to day four. Day four. Today is the last day. I can't believe we've been running for 2 weeks. There's been a lot of people who joined in. There are a lot of people who watched it offline. I'm really thankful to you all for taking out the time to do so, and sharing your learning with us, and giving us the opportunity to share our learnings with you. Sadly, this is the end for our session. This is going to be the last one. We hope to do more next year, based on the feedback we get, how people take it. But we're really happy on that we took the opportunity to do this, gave you guys the opportunity to learn and ask questions. Um, Before we get started for today, there are two links I would love for you to check out. There are two QR codes. Number one is you can join our Discord community, and the second is that you can explore our GitHub, where we have all the N8N articles where listed. Um, 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 so we can sort of see through them, and be able to so you can sort of go through them. I do sort of see your comments like, if possible, please send this YouTube link via mail. There's no mail on today's session. I think we did send an email. Maybe it got lost in translation. Something did not work out properly. But guys, this is the first time we're running a cohort with like this. So there are a lot of unknowns, but we'll definitely try to make sure that we are sending out more emails and checking in on those setups. But check out these two GitHubs, these two links. First is the Discord community, and second is our GitHub link, where we have all the N8N articles. As for just a reminder, my name is Hamza. I'm a founder CEO of Traversal AI. We help companies build vertical AI agents. Previously at Google, before that I was at Walmart. Quite a few years in machine learning, and I'm currently serving as a adjunct professor at UCLA. And I've previously been with Stanford Continuing Studies, University of Minnesota, Santa Clara University, and a bunch of other places. This course wouldn't be possible without the course facilitators who have worked together with us, who sort of worked behind the scenes, putting it all together for us. They have done a great job in bringing together what we have learned, what is possible here today. There's a lot that goes behind the scenes, to build things, and they have done a great job in putting it all together for us. Recap: we had thousands of people who signed up for this course. I think we had about 6,000 people who signed up for this course. There are a lot of people who are doing it offline. Apart from that, we also teach these courses, teach live courses to people from across multiple universities. There are two major ones, Stanford Continuing Studies, and there's the second one, which is at UCLA. These are both university-oriented courses. However, we have the opportunity to teach these courses to folks around the world. So after this course, if you're interested in learning more about this, about what we teach, you can scan this QR code. This QR code will take you to take you to one of our courses, which is the Agentic AI System Design for PMs. It's one of the highest rated courses on Maven. Maven is an online platform. Those of you who have not seen before, you can scan this QR code. There is additional discount for you to, if you scan this, you should be able to see an additional discount. um, so you can sort of check it out. Second, if you are a developer and you would like to learn more about how to, as a developer, or you would like to build this course, this is a link over here. This is again another QR code. I think we have too many QR codes now, but this is a QR code which you can basically follow through if you'd like to enroll in our developer version of the course. Again, we're live streaming this on YouTube. This YouTube link will be available for you after once the stream ends, so you can always bookmark it and you can follow through. Most important thing is we want to give away 2 scholarships for this course. We would like people to and as many people as we want to, as we can enroll. But most importantly, we have 2 scholarships for this course. We want people to to join our session. So all we ask you to do is write a post about our course. Just spread the word about what we're doing, how we're doing. One key takeaway, and then you can scan again the last QR code. We'll send you an email about it. There are too many links and things to follow. But what you can do is you can sort of check it out and sort of see about these courses. This QR code, which will help you enroll into you can submit your interest for scholarship, and we'll be able to enroll you based on that. So day one, we talked about agents. We talked about what are the different levels of agent, and we built a simple end-to-end implementation of Lisa, which was sort of a perplexity clone that would answer internet questions that would require internet search. Day two, we did a recap on from basic keyword search to enterprise RAG. We talked about agentic RAG. We talked about routers. We talked about how they're built and what goes on onto building those tools. What are the core building blocks? Day three, we looked into React agents, which was yesterday. We talked about how do we go from, what does it mean to go from level 2 to level 3, how to bring in reasoning. We talked about React agents. The React agents played a major role in terms of how the framework was created. How do we add reasoning to ecosystem? And then last but not least, we discuss a lot about memory. Today's session, what we'll do is that we'll talk about how agents interact with each other. What are the building ecosystem over there? We'll go through 2 coding notebooks. We will go through Crew AI, which is the first agent to agent ecosystem, and then we'll go through the second one, which is A2A ADK with MCP connectivity. Those things will sort of play a bigger role in making sure that we're able to build something better. We're able to see how multiple agents play a major role in connecting and talking to each other. In terms of complexity and deterministic workflow, just a reminder, you have simple LLMs on the left, all the way to the left bottom. Then we have LLM with tools, which you saw with NNN. Then we have LLM with the reasoning capability, which is the top right quadrant. And then we get agent to agent ecosystem, which is the top right, which is they have very high autonomy, and they are much more complex than any other ecosystem that we have worked with. This is not science. This is not scientifically driven that these are the only way that we can represent them. But what we see over here is that they are built out in a way that we can sort of distinguish them in how they're built out, and their capabilities, and the strength that lies behind the scenes in building them. So we discussed yesterday agent. So React agent, we discussed, they uses reasoning and acting. There's a React framework. It combines chain of thought reasoning. And what it does is that when somebody asks a question, there's an LLM in the middle. It thinks through the different things. or how to make a plan of action for you. Once it takes thinks about it, you can take a certain set of actions. You can then observe those actions which are taken by those tools. You pause, you evaluate how good the answer is. Did it converge? Did it find all the things that it was looking for? Once it has found that answer, it will go back, and then basically based on the evaluation, say, okay, I have found the answer. Now I know what you're looking for, and then it uses all of that to generate an output. So React Agent do play a big role in building out our ecosystem. Um, a lot of tools, Lovable, even I think some form of Perplexity, they're all React based agents. At least how you look behind the scenes. So when you ask Lovable to build something for you, it's using these a React agent behind the scenes to sort of come up with a plan, which enables the reasoning for them to generate an output using different tools. Just going a little deeper, we talked about memory also. In the memory, basically, if you look at this architecture, you have an LLM. In the central theme, it has access to different tools which are on over here. And then what you also can have is that planning agent, which will have reflection, self-critique, chain of thought, prompt decomposition, which sort of helps it do a better job in coming up with how it wants to respond. And finally, there's a short-term memory and a long-term memory. The short-term and the long-term memory basically play a hand-in-hand role in making sure that we are able to create a great user experience, and the agent doesn't hallucinate in individual steps. It continues to stay on those steps to generate a decent output. Um, Memory module, as I said before, it has short-term memory, long-term memory, and they play a major role in making sure that we basically use them to help us remember previous conversations or intermediate conversations that are happening within the session. So an example would be, remember when we discussed the marketing budget last week? Based on that 50K constraints, here are updated recommendations. All right. So now we're going to talk about something interesting, which is agent to agent. And I don't have a lot of slides today. I want to try to talk about code as much as possible today. But agent to agent, this is something which sort of have taken over, where we, instead of having one agent talk to different tools, we can have multiple agents that have tools built within them. One of the agent ecosystem that exists like that is Crew AI. Crew AI is a framework for building collaborative multi-agent systems. It lets you define agents with roles, goals, and tools, and it basically does an entire orchestration. So remember, I showed you React agent, which had one agent that had access to multiple tools. These are multiple agents with access to multiple tools. However, one of the good things that you can do over here is that one agent can do one single thing only. Again, the great thing about this is that one agent can do one thing only, which makes it really, really good use case when we are trying to build out something. If we don't want our agents to fail, if we don't want them to have a large failure, we reduce the number of tools that is available to every agent. However, we use the agent, we sort of call them micro agents, because they are doing pretty much only one or two jobs within them. This helps us improve the output or the outcome of our agent altogether. So Crew AI plays a major role, or it's a major task or orchestration role that helps. For that purpose, what we have done is that we've created, we saw an example online, and we tinkered it a little bit to build to our use case. So basically, you have a notebook. In the notebook, the job of the notebook is to find AI news. It's an AI news researcher agent, which finds fresh news AI headlines. And you can also use Google search for this. I mean, there's no problem. You can just say top fresh AI headlines. But what it also does is that it sort of creates a summary, and then it also creates writes a detailed 300-word analysis on one of those news articles. So what the tool does is that it has two agents within that. It has an AI news researcher and an AI sort of story investigator. What they do is they work hand in hand. The first part looks for articles or looks for the latest research on that was released, in the past 1 week. The second one picks up one of them and sort of writes a 300-word article on that. Now you can also use Annotate on this, but the idea behind the scenes on this one is that it has sort of thinking capability that it will go in iteration until it knows that it has what it needs to answer the question. So it's an iterative process. It does not go in one go, it does not go in one flow. It goes back and forth. It disregards a lot of code or things, and it says, okay, based on what I have, I think I know what I want to work on, and this is how I'm going to build. So as I move forward, I wanted to ask people over here on the call, how many of you have used Crew AI, or how many of you have ever worked on Crew AI before or are aware of it? This way, it will be really useful to learn from, as I show you the document, as I show you the code, you will be able to relate to it. So here we're going to do something different today. So what we would love for you to do is follow along with us on this as we build this code. So what I'll do is I'll share the link directly in the chat. I think there are not many of you here today, so be easier to connect with you all here. So what I'll do is that I'll drop this link in the chat. You should be able to see this comment. You should be able to open this for yourself also. And I would really like you all to follow along in coding this with me. There's not a lot of code that you need to write. I'll be honest, there's not a lot of code you need to write today for this. But what I would like you to do is we want you to be able to generate an output. It has two or three things you need to sign up on, which are all free right now. So you don't have to worry about paying for anything. All I would like you to do is sort of just get a hands-on opportunity to running an agent. And this is by no means an exhaustive agent. This is a agent or a multiple series of agents that we have stitched together that are easy enough that we can run in one class. Usually, agents take more time to stitch together and to explain their code. Here we have something which is available to us, and sort of we can build out an architecture from them. So um, let me know if you're able to access this Collab notebook. This Collab notebook is exhaustive on its own, which means that you don't need to connect to anything else in terms of dependency or anything. Everything that you will learn or run will be on this Collab notebook. You just have to sign up for a couple of things. We'll talk about them, but you should be able to use this. And this is something like a autogen. So if you have used autogen is similar to Crew AI. If you have used LangGraph, LangGraph is also similar to Crew AI. So they're not very different from each other. It's some one came before the other, or how easy one of them it is to work with the other one. So without further ado, I would love for you all to open this Collab notebook. Uh, Again, I would like to confirm if you guys have access to this, you're able to click on the Collab notebook to from in the comments given to you, so that you can open it at your end. So what I'll do here is when I come here, there's an explanation about this is our agent bootcamp, and what we want to do is it turns a simple notebook into a capable AI newsroom where specialized agents work together to track fast-moving AI news. By breaking workflows into roles, we get a process that's modular, auditable, and easy to extend. It can decide what to search, which stories to keep, how much depth each story deserves. And so basically what you're doing is that you're adding a thought process behind the scenes for all of them, so that people can sort of use these agents in an iterative way rather than a one flow. When I say iterative, it means that you independently allow it to think on its own that this is the right way to come up with an answer. And then over here, what we have is a researcher agent and a story in investigator agent. So if you guys have been following previous sessions, there is something what we use, Aries Web Search. This is our own version of Perplexity. We built it because I teach about AI search or search so many times, and I didn't want to pay another company. So we built our own version of Perplexity. So you can use this as a part of your ecosystem. So we have live internet search, which is used by the researcher agent, and the story investigator agent is that take each shortlisted headlines as input, runs additional targeted search to gather more context, and then writes a 300-word source backend deep dive explaining the story, technical details, and broader impact. All right, so again, this is the workflow, but these agents are orchestrated with Crew AI. Task one is discover the latest news, and then task two expand each story into detailed analysis. Here, what we'll do is that we'll pick up one major story and use that major story to explain what's going on behind the scenes. And all the outputs that we see here will be saved in Markdown that you should be able to view over here on the left. All right, and this notebook has been, we adapted this notebook from this OneDB table link. We have also shared the link, so if you want to check out what weights and biases are, this is an amazing company. They do some really fun stuff. So we picked up this example, we tweaked it a little bit to match to our, but this is the original link that is available online that you can follow. All right, so first we'll do is that we'll start with in the installation. As you will see the installation happen, you will see that it will sort of restart. This will definitely restart once. If it doesn't, because I've already run it before. But for most of you, actually, what I'll do is that I'll delete runtime and start again, so that we all have the same experience. All right, so you hit pip install. It's going to connect. And one of the limitations, or the things that is important for LangChain, for Crew AI, is to have LangChain included in its ecosystem. You can also remove it, but most of you or some of you have been working with LangChain, so we didn't want to sort of discriminate on not using any LangChain examples. We just wanted you to be able to work with something fast and be able to build something from there. All right, so we are downloading all the needed Python packages. If you've never run Python, there's no problem at all. You don't have to do anything else. You just have to hit run. Just hit the run button over here at the top. That's all you need to do. You don't do run all, because that won't work. But there's a stop and a play sign over here. All we need you to do is the run that stop and play button. Just hit run, and that should run. So the first thing you will see is that it will tell you to it will ask you to restart the session. So you go ahead and restart the session. Because there are a few packages that have been reinstalled, so make sure that all of them are up and running. So once it says that you have to restart, you have to go back to the top and sort of run the first thing again. So now that we have everything installed, the second thing you need to do is basically install Aries API, or add Aries API to your ecosystem. This is basically how you would use internet search. So the way you would do is that you would go to this link, api.traversal.ai, and so over here you would land at this page. If you just sign up or log in, so it will just tell you that how much balance you have. I, of course, I own the company, so I have a bigger balance. But you can go. Usually, you should see 100 over here. From here, you can go to keys, and you can create a key for yourself. So maybe I can run a different tool. So if you log in over here, let me try a different email address. Okay, I don't remember the email of this one. Let's try this one. All right. So I have about 42 requests remaining over here. In order to run this, what you can do is go to keys and you can create a key. And as you create a key, it will give you a key. You can copy this key. So you went to keys, you generated a key, you copied the key over here, right here, and then you can go back to your ecosystem, and then you can make a new key over here. So there's a really good way of storing keys in Collab Notebook. If you go to keys over here, you can write Aries API key over here, which is the name, and then you can paste the key over here. If you like to build one, you just need to do add secrets, and you can write, for example, Aries. You can write Aries API key, and you can paste this. Only this way you have a key available to you, which is stored. It's not visible by other people. However, it is always available to you whenever you need it. So it's sort of an environment file. If you've never worked with it, it's fine. It's not going to take you a lot of time. If you don't want to do anything, you can just paste the key over here. So if you're like, I don't care about this, I don't have the time, you can just paste your key over here. This is also another way that you can work with that. You'll also have to paste your OpenAI key. But what I want to suggest is there's a good standard that you can save your keys over here on the left. Once you have saved your keys on the left, you should be able to set it up. So I'm going to pause here. Any questions so far and from anyone on what to do? All you need to do is first go to the Aries API key, create the Aries API key, and have the OpenAI key available. Once you have those keys available to you, you should be able to generate, or you should be able to set up your environment variables. Those environment variables will give you access to APIs that are available to you to run this agent. All right. So once you have done that, you can initialize it. You can initialize the class, which is the internet search. This is much like a tool where you have defined that I want to receive a question. Once I've received a question from the user, I would like to generate a response. So you basically just initiate that class over here. Here, there's another interesting part is where we can use Weave. So weights and balance, what they have a great thing is that you can enable tracing. So what that would do is that it will sort of follow along on the whole process of what's happening behind the scenes. All right. So here is the entire code for what you need to do. Basically, what we do is that we initiate Weave. This is basically responsible for running our agent. And all you need to do is it will basically try to follow along everything that's happening behind the scenes. It's sort of just making sure that as you run through everything, it basically just records the entire log of what's happening behind the scenes, right? And here is how it works, how these agents work. You have the research agent, and then you have the story agent. The research agent, you give a backstory. This is the role. You give a backstory. An AI-focused journalist specializing in breaking news and emerging trends. Find the most recent AI news from the last 12 hours. If it's not within the last few days, do not include it. It has a search tool within that. So remember how we created the search tool? This is the search tool. So this agent has just one tool in it. And the only job of this tool is to do internet search. There's no other requirement from this tool or what it's supposed to do. All its job is that it should run internet search behind the scenes. It cannot delegate its job. That means that it's not allowed to send any request to anybody else. all it's supposed to do is just respond to the request that is given its way. And then we basically want to we identify that how many iterations you want to run. So basically, if it errors out after third, it will stop running. And then which LLM are we using behind the scenes so that we can run this tool. Secondly, you have the story researcher, which job is that with expands on initial findings, gathering additional context, sources, and insights, and then basically it will do in deeper research on each one of them, each one of the information that was given to us, and then all its job is to sort of find out what right, which is the most important one, and sort of build from there. And here you have search for the most recent AI news, published, extract five most important developments, including company names, AI models, and so on and so forth. And then we would like you to create an output, a list of 10 most important AI updates for the last 24 hours. This is the expected outcome for the research task of the research agent. So you see, there are two things that are done. You define the AI agent. So here's your researcher, which you define, and then you define the task. So it's a very intuitive tool that you can use. You can sort of you first define the AI agent, and then once you have defined the AI agent, you then define that what it is supposed to do in the task. So this is how sort of these agents work. You first define them, and then you first define you define them, and then define the task within them. And you also say, this is the description of what I want you to do, and this is the expected outcome output, and then this is the output file that I would like you to save the information. On the other hand, you have the story research task. Basically, what this will do is that it will basically ask you, take description from you on what it has you've already given from the research agent. And what it will do is that it will write a detailed 300-word analysis for each. Usually it ends up just writing one, but it basically there's a detailed 300-word analysis, and then this is saved in the expanded AI news. All right. So Crew AI, what we have done is that we've sort of built a tool that goes around trying to find answers to different questions, or tries to find information about research, the top research that has been done in the past few hours, and then it tries to build expanded news article based on that. Right. So this is the job that we have given to Crew AI. It's definitely smarter. That requires you to think more and more about how to get to the finish line. It is not sequential. It basically, yes, it says sequential over here, but it has an ability to think, reflect, and then generate a response based on what the user have asked. All right, so we'll start with the process, and I think the first thing it will do, it will ask us to log in into Weave, so that we can generate a key that will be able to log all our activities. So starts to run. It takes a bit of a time to figure out what it needs to do. So here you will see that it says, hey, you need an API key of WantDB. So if you go to the website, website, let's figure it out. Okay, share this time. All right, so if you go here, you log in. This is the key that it will be generated for you. So you copy this, you come back here, and you can paste this key over here. So now this says, this is execution started. And I think you should be able to follow along what's happening behind the scenes if you go to your WantDB, you should be able to see how your projects are running. So over here, if you see, it will basically tell you that, we just started out this action, and how are we trying to, store all the information that is going on over here. It basically looks at it tracks everything that is done behind the scenes. So this is a great tool for observability. So if you haven't worked on observability, this is your time to sort of understand how observability works. It's basically storing every single output that is generated for you so that you can trace every single thing that has happened previously. This is a very powerful tool. I would really suggest you guys to check it out. They're not dead. These guys don't endorse me. The only reason I'm showing you this is because these guys do a great job in putting good observability, which sort of helps us build our tools better and be able to evaluate performance. All right, so I think it's still it did run. All right, all right. So, oh wow, so it was able to run first of them. Let's try it again. I think the internet search didn't work. Let me try again if it works. Sometimes there are errors that we see. So it gives you the idea, and it's good to see that sometimes, if everything works great, then you always are able to get a glance. So for some reason, the internet search is not working. So I will check again if the internet's capability is on. Hmm. So it's still running behind the scenes, trying to find answers. Okay, something is running. Interesting. I'm not sure why the API is erroring out right now, but let's see if it's set up over here. I'll try to paste the key here again. So this is the fun part about demos. Sometimes they don't go as you expect them to be. Of course, it was running a day before, but essentially, what it's supposed to do, it's supposed to run behind the scenes, connect to the internet. So let's just say we have this set up, and let's try again. And if it doesn't run, it will still create an output for you, which is very interesting. That the output will still have information available to you to showcase that, hey, we have an output. This is what happened behind the scenes. Here, if you see here, um, if you see here, there will be expanded AI news and latest articles that it has generated. So if the tools don't work, it still ends up creating answers based on that. So you have different researcher which is running. So I think the internet searches were running now. It's going to generate answers to the output. Let's wait for it. Essentially, this is what you should see. You'll get a set of latest AI news over here, different information that is being gathered over here, and then from that, what it will do is that it will go to expanded AI news and sort of generate an article about, I think about at least two or three of them that it found that they are most important for you to generate a response. right? And just give it to, what we'll do is that it's rerunning the whole thing with internet search, I think, which is running now. So let's wait for 2 more minutes. Usually they take about 2 minutes, 3 minutes to run, if they have been fully run in terms of the requests. And once we have them, we should be able to see how the output looks like. It's always fun to see an API go down when you're trying to run a live session. All right, so this ran, and we can look at the answers over here. So here we have the articles which are generated for us. So here you can see the internet search work. So this is an article that was published today. Let's open this. So it found an article that was published 6 hours ago. So it was able to pick up information that was published very recently, and sort of it's highlighting those, those latest news articles for you over here. So all these things are done live, like they're all very recent output. So again, this is an article that they found less than 24 hours ago. The article is AI gives scientists a boost, but at the cost of too many mediocre papers, which is true. We are seeing a lot of papers that are not coming to life. So, so the good thing about this tool is that when it works, and it does work a lot of time, one of the reasons when some of these things fail is because of the fact that they have tools that don't work, or they have challenges with them. So over here, all of these articles you will see, these articles were published within the last 24 hours. So if you imagine that you want to build a newsletter that has the latest information that is being sent to you, this is a great place to sort of find out. This is a great tool to build. So this is all your latest AI news that was created. Once this is created, what you can do then is, if you go back here and you look at the expanded news, so the expanded news will pick up one or two most important articles and sort of write overview about them. So AI boost paper production for non-native English speakers. This is the same article that we just read, which was published, I think, today. It uses those search examples to come up with what happened. Then, tech giants investing heavily in AI infrastructure. So the good thing is you can actually go through what's happening. You can evaluate how it worked. You can see the failures, you can see the success. And once you can see all of that, you are able to evaluate and say, okay, you know what? This is good, this is bad, and this is how I would like to follow along on this. So I feel good about these things, that they're tool dependent, but once the tool works, they generate significant output for us, which takes a long time that it would do for us if we are, if we have to do it ourselves. So the good thing about this tool is that it gives you observability. So it will tell you every single thing it did. You see, it did about 18 different internet searches, and it identified that when should I use it, when should I not use it. So essentially, what happened behind the scenes is we had the first tool, the AI news researcher. It found links to most updated news, or it found news articles. So the AI researcher had this final answer that was created. It found out articles that were published in the last 24 hours. You can see each one of them have dates of today. So that's one thing. The second thing is that the story navigator, what it did is it sort of searched for additional details. So we basically looked at every article that was published, and then or the small article, and then we did additional search on those articles to find out more information about them. And once we found out more information, it said, so you can see, I thought I need to gather more insights on the impact of AI on paper production, especially for non-native English speakers. and the associated quality concerns. So it sort of did an internet search which says AI boosts paper production non-native. So it basically did the internet search. It kept doing the search, and then once it had the answer, it sort of said, "This is what the user request was. This is how I've generated the answer." So it's pretty exhaustive in how it works behind the scenes, what it generates for us, and the level of automation that we get is not just because, or the level of automation is not because it's a single line flow. It's basically going back and forth until it knows that I have the right answer. I have generated a good quality output, and once it has generated that good quality output, it basically makes it, pushes it for it pushes it and says, we have the answer, and it's done. So I don't know how many of you try to follow through this to write the answers, um, and you've been able to run this from start to finish. But this is a great example of seeing how tools work in life. Sometimes, you have to make sure that all the API keys are working. I'm not sure why my API key went down at this particular time, but nevertheless, it's fun to see, how sometimes things work well, how sometimes, they fail. And I will also show you that previously I think I had 46 remaining 46 requests. It reduced to 38 because those were the internet searches that were done behind the scenes to sort of generate responses. So in order to build better, one of the best tools that we need to have is internet search and RAG search, because they do a great job in building you a good product. You don't want hallucination. When you don't want hallucination, you want to use grounding architectures. Grounding architectures, when you have good search tools running behind the scenes. I ended up building my own because I use internet search in many forms in many of our tools. This internet search plays a big role in making sure, that all the requests that are coming are successful, or at least I'm not paying a huge buttload of money to another company. I'm able to generate answers on my own and use these tools to build that. If you don't want to use our tool, you can use Serper in this place. There's a Serper tool that you can replace with internet search. You can do Brave search. You can do many different searches over here. You don't have to use what I have built. You can basically replace this search tool with your own search tool. Again, you can use Perplexity, you can use Brave, you can use, I think there's a company called Exa. There are many companies that offer API endpoints for search, DuckDuckGo. You can use them so that you are able to then get the right grounding. Once you have the right grounding, you're able to generate a response out of that. And the grounding will help you sort of generate better output. All right, so I'm going to pause here. I've covered a ton of topics. What I would like to do is I'm going to pause here and try to answer any questions that you guys might have for me on how it works.
Hamza, while the participants can ask other questions, let's start with the questions that we already have. Uh,
Yep.
the first question is, in yesterday's session, we discussed about how libraries such as LangChain, LangGraph introduces abstractions. I'm curious if the risk of abstraction is any different than QEI.
Yeah, so one of the things that happens in Crew AI is that it depends on LLM observability. So Crew AI uses LangChain. I mean, it can also not use LangChain, but it uses LangChain for calling an LLM, which basically creates an abstraction. So let's say the API architecture changes, then you have to make sure that you are adapting to that architecture of Crew of LangChain when you're rewriting your code. So I'll give you an example. When I start this thing was written like 3 months ago. However, when I ran it, the architecture for LangChain had changed. So we had to update the coding notebook. We had to update the coding notebook to match the new code or new syntax for LangChain. So these things are always there. We see them as a problem, and they create a lot of challenges for us.
Thank you. Uh, So, the one question regarding the agentic AI newsroom, uh, how do we handle the time? Because is it sequential?
So it can be sequential. It can be it sort of depends on where you're going with. Usually, what we say is that so sequential basically means over here is that first I want you to run the AI researcher, which is going to find the top news, and then I want you to go to the AI investigator. That is the sequential part over here. It's not sequential in the sense that how we have n that n goes from one point to the second to the third to the fourth to the fifth to the sixth. Here, it's basically built on the fact that we are trying to follow along questions, or we're trying to follow along a flow. So we do want one agent to work before the other in order to create. So it's like a dependency problem.
Okay, thank you. We have just these two questions.
All right.
I think you can ask us any question that you have.
All right. So let's try, let's switch gears. And what I would love to do is I want to hear from anyone who has been able to run this code from start to finish. And if they had any challenges in setting up anything, because this is how you sort of you get a good idea about how these things work, and how they are built out. All right. So, and if there are not many questions, we can sort of end early also. Give you guys your Friday back. All right. So coming back here, and back to sharing my screen. All right. Okay. So here we have, we just discussed the multi-agent architecture. It's very simple, but it's very powerful in what it can do. And I want you to know that there's a failure rate associated with every agent not working. That's why you need to have observability and evaluation criteria to build out something. All right, now let's go on to the next part of today's session, which is agent to agent protocol. So agent to agent protocol is something that was built by Google, and they open sourced it to the Linux Foundation. So it's now available as open source architecture. This is, in my opinion, the most industry oriented or the most industry production ready ecosystem. What it does is that it can basically use any agentic framework. You can put LangChain, you can put Llama Index, you can put LangFlow. I think you can even put Crew AI within this. However, what it does is that its job is not to run the agent at the basic level. Its job is to make sure that the agent is able to run in sync with other agents. So think of it as a little differently. You just build a news researcher agent, right? Let's say you want the news researcher agent to sort of work with another agent that builds you beautiful newsletters. It designs and develops them independent. So you basically are sending a request to each one of them, and it sort of builds from there. So and here what's happening is the A2A protocol sort of enables us to interact with those tools. So think of A2A as a place where you can place an agent that you built in LangChain, an agent that you built in Crew AI, an agent that you also built in ADK. So ADK is Google's agent development kit, which is useful, which you can use to build your own agents, which is something like Crew AI. So ADK is Google's agent development kit. A2A is a protocol that allows you to have many agents work in sync with each other, with each one of them built independently to do a certain job. So this is a very cool tool. This is a very cool tool in how we build on how we build production level, because you can't have one. You can't. We recommend people to have an agent all in one architecture, but sometimes you have already built an agent and you don't want to rebuild it from scratch because you were able to use in Crue. That's no problem at all. You can just connect that agent to another agent through the A2A protocol. What it does is that it allows you sequential, parallel, and loop workflows. What it does, so that means is that You can build a sequential workflow, you can build a parallel workflow, you can build many different kinds of workflows that they all have, that they're all available. It supports text, audio, video forms, and iframes. It uses HTTP for transport between clients with JSON. So it's basically pretty secure. Um, and it does not share internal memory. It only shares the most relevant information that should be passed along with each other. So you define that. You say, this is the only information I want you to go back and forth with these tools, and that is what it's built on. And then it has built-in authentication and security features. So this is an example of a Google ADK A2A MCP capability over here. Some of you might not have ever heard of MCP. We'll talk about MCP in a minute. But this is a very good framework that you can see, in which you have a user query, there's user authentication, there's an input guardrail, then it passes through judge agent, which has different checks between the scenes. Then you have a SQL agent. The SQL agent converses with the MCP client, and then there's a masking agent on the right. So if you think about it, this is one of the fanciest tools that is built out, that you can build out very fast, very easily, that has the capability to sort of work behind the scenes and generate some very good production level agent to agent architecture ecosystem. This has been something which we as a company have adopted, and we have been using across multiple many of our customers to build these tools better and sort of explain what's happening behind the scenes. Now, one of the things I mentioned here was MCP, and I'll just explain what MCP is. So some of you might have heard the word MCP, some of you might have been reading about it, some of you might be saying MCP is dead, even before it came to life. And some of you say USB APIs are dead. There are all sorts of hype. But I'll explain you the basic hype. Before when we were using tools, so anytime you use a tool, you have to design the API. So in the AI news researcher over here, I had to build a tool, and within the tool, I had to define all the architecture for API infrastructure and sort of so on and so forth on how it connects. Then we would design a layer on top of it, in which we would discuss on how to build that architecture, like how to converse with that ecosystem. What MCP does is MCP does something differently. What MCP does for you is MCP allows you to have one unified layer that will speak to all different tools. So MCP enables LLMs to connect to APIs without designing a specific layer or like an additional layer for each one of them. And it has been sometimes a hit and a miss, but it has been it does perform really well when it is set up correctly. It does the job of what we want it to do. It doesn't run in a lot of trouble when we are designing them. So I would really want you to try out how MCP works, and see the see different examples on how we connect MCP to different tools. One of the examples that we have is we have built a complete end-to-end architecture for ATK, in which you have a input guardrail, a judge agent, a SQL agent, which is connected to a MCP server for SQL, and then there's a masking agent which finally generates an answer. So with an MCP, you can standardize agent tool communication, you can secure external access, and they have a plug and play. So what we do is, in order to connect in order to connect an LLM with different tools, you have to design a separate API for each one of them. With MCP, it reduces the amount of work that you have to play. So the word plug and play integration works. So think of it as a USB-C for all different APIs that you have. And we use a lot of APIs. So here in my previous example, I showed you just one tool. but we can have like 10 different APIs that are connected to our ecosystem. MCP sort of abstracts that, and it's built on with an MCP server, which is connected to a client. The client is then connected to LLM, sort of to generate a response for you. And it really plays a big role in reducing the amount of work you need to do to design connectivity to different tools that you might use in your agent architecture. There are some core components of MCP. There's MCP host. So the hosts are basically like programs like Claude or IDE or n8n. The client basically that maintains one-on-one connections with the servers. The servers are the lightweight programs that sort of use the API endpoint to sort of build that, and then there's local data sources and remote services. But most importantly are these three things: is MCP hosts. So MCP host are the tools that you are running behind the scenes that receive your prompt. MCP client, protocols that maintain one-on-one connections with the servers, and the servers maintain the relationship with different tools. So you can use these different things put together for the LLM to sort of converse behind the scenes. So when you ask a request, you don't directly ask an LLM. You ask a program. So, for example, n8n, you ask Claude a request. Those are MCP host. Within them, there's an LLM. The MCP clients maintains that relationships and runs it with the server to sort of generate a response. And at the end of the day, this is the most important part for you. MCP is to LLMs as APIs are for tools. So I want you to sort of just remember this part. MCP is an API connector for LLMs where APIs cannot directly talk to an LLM. MCP enables that upper layer that enables you. So the key differentiator between MCP and API is the intended users. Agents can't use APIs without the necessary tools built on top what is already there. So public APIs are helpful, but only a portion of the infra that needs to be there. MCPs are designed for LLMs to call APIs without extra setup, whereas APIs require a developer to build that tools manually. MCP act as wrappers around API. So, what's a great example of an MCP? I would like to show you all one of them. I keep sharing this example with everyone. This is a tool that we built that connects to Airbnb, does internet search, or does the search for me. So for example, if I say I want to go to a modern apartment in Tokyo, of course this is the wrong, we've already crossed that. So let's just say I want 20th January to 23rd January 2026. I'll put my full name and I'll put my email address, and then I'll hit search. And what it does is that it runs behind the scenes with an MCP server connectivity. So I just want to say that I did not design the connectivity to Airbnb at all. I'll show you guys the workflow. This is the workflow. So I don't know how to connect to Airbnb and read Airbnb ecosystem. I have no idea how that works behind the scenes. All I know is that there are MCP connections that are available that I just need to introduce them in my ecosystem, and it will directly connect and it will run behind the scenes and sort of just work, do everything that I need to do without me requiring to set up anything. All I did was literally just drop these two MCP tools, and it's connecting to n8n on its own, it's connecting to Airbnb on its own. It's generating a response, it's finding the most relevant information for me. And once it has found that information for me, the best thing is, if you go, this is my actual inbox. I just received this email 0 minutes ago. You can actually see these responses. You can see how they are set up. And then if you click on any one of them, it shows you the most relevant details that are needed. So this tool is actually pretty fancy when it comes to the ability for MCP to work. So again, I have no idea. I have no idea is how do LLMs how do MCP work. I All I did was get an MCP, add it to my n8n infrastructure. The n8n infrastructure connected to MCP. The MCP basically ran behind the scenes, connected to Airbnb on its own, executed different requests from that I sent, and then it created an email that got sent to my inbox, which is right over here. Right? This is how good MCP is, that it's able to read information for me while I have no idea what's happening. And while I don't know how to design an Airbnb connector, we just built one ourselves. And if you want to see how it ran, this is the entire information. Like, this is the execution that I just ran three minutes ago. It will tell me where did the request come from, what was the exact request, modern apartment in Tokyo near train stations. So you see, all of those things are logged, and over here it will show you how it ran, what it created. So you see, it did the check-in, check-out date, and it just kept running until it sort of generated an output for me that this is the most relevant details, and it's not hallucinating because it's giving you the right links of what the right links, the right properties. So if I were a developer and I did not have MCP, I would have to spend hours and hours trying to figure out how to connect Airbnb. Here, I didn't have to. All I did was drop the MCP server over here, and it was up and running. Now, if you would like to learn this on your own and you want to see how all of this works, what I would love for you to do is, I have written the entire journey on how to build it. Okay, um, I'm not going to show you anything that I'm not going to share that is not already built out, or you have to pay for it. All I want guys to do is learn, actually. So I'm going to try to figure out where this post is, but yep. So here, let me just open this link. So this is an article that I wrote, the unofficial Airbnb AI agent. This one walks you through step by step on how to build this tool yourself, how to build the entire ecosystem yourself. I'm going to put this in the link. And you basically, I'm going to put this in the link. I would love for you guys to follow through, try this out, like, um, build it yourself. And this by no means is an exhaustive tool. Please know, none of these things are exhaustive. They will error out, they will have challenges. However, we are looking at what's the art of possibility, how it works, how it's built out, and then you can implement all of this by yourself, using the from our GitHub. Actually, I'll also take you to our GitHub. On our GitHub, we also have an entire explanation on how we built it. Give me 1 second. Yep, right here. This sort of explains everything that we are doing, and then you can go to the n8n, the workflow right here. The workflow will basically explain what you need to do, how you need to set up, and you should be able to go from there. So um, this is what I'm trying to sort of showcase, in a way that this is what's happening behind the scenes, and this is how it's sort of built out and what it does, and when we're trying to build these things. All right. Okay. So coming back to this part, let me share my screen. All right. So APIs. are for developers to connect to different tools. MCP is for connecting to LLMs so that you have much lower layer of abstraction when you're building a tool. MCP limitation exists in multiple forms. You know, MCP basically is limited by the tool itself. It's just not built for scalability. In some use cases, there are many different webs, products which are coming on, which are improving MCP connection. So Fast MCP 2.0 is a really good architecture that I would recommend you all to use, so that sort of you can learn from it. You can see how it's built out, and you can see what works behind the scenes over here. So MCP is fast growing. MCP has a lot of capability, and MCP sort of offers this as an endpoint for people to love. Okay, so for Google ADK, um, here we did A2A, we discussed A2A, we discussed ADK. Oh, sorry, we did discuss MCP. I just want to end this topic with talking to you about Agent Development Kit. ADK is basically a self-contained execution unit, which basically it can form the same things that we saw in Crew AI. So ADK helps you build agent. A2A enables you to connect those agents. So these are two different things. ADK, you use it like Crew AI or LangGraph or LangChain to build an agent, and A2A allows you to interact with different agents that you have built using ADK. And here you usually have, the architecture basically is that is the base agent class. It serves as a fundamental blueprint. There's the base agent. The base agent has an LLM based LLM capability, and then it has a SQL agent, parallel agent, loop agent, and then you can also have a custom agent which follows a certain protocol. So the way it works is that when you get a customer request, or a customer has requested you for something, it basically goes back and forth in order to create and understand what your user request is, and it sort of divides and conquers the approach. I'll show you an architecture that sort of will help you identify. So here we have a customer support agent. The customer support agent basically says, "Hi, this is my name." It says, I want to know the update to my order, which is this number," and says, "Here are the details of your order." Here, what you can see is that it's running sequential in loop. So there are different tools which are connected. This is the main orchestration agent that is connected to a database through MCP. There's something which we call mem0, as I showed yesterday, which is the memory box. From that, it can give you order status. It can find customer orders. Those are also connected to a SQL databases. So just want to say that there's a huge architecture design behind the scenes when you're trying to build, these agents using ADK. There is usually a main agent. That main agent is also connected to other agents that are finding related information for you. You have mem0 connectivity, which is your memory agent that sort of enables you to remember user preferences, or what previous conversations we had with the users. Here you basically have user input. You have a Google ADK runner, which has session management, event processing. And then from there, we basically have the Flash 2.5 agent, which basically finds the right tool that it should reach out to find, either get the user order status, find customer orders, and then we sort of put it all together to run this. This is the entire code base that you can sort of follow through in order, if you want to implement it. This is a lot of code that is needed behind the scenes. There are many moving pieces of this, so it takes a bit of time to build it out. However, this is what makes it great. This is what makes it so production ready, that it has many moving pieces that are all maintained by Google. And I would say this is one of the best that I've seen out there in agent architecture, and it does a great job. All right. All right. So We are almost at the finish of our series. We have about 12 minutes left, so I'll try to explain what's next. Um, what we would like you to do is, and as more people watch this video, we would love for you guys to, we'll make a group on, we're going to make a group on our Discord, where we would love for you to submit your ideas, that if you like to, if you would like to come and present, and we'll do a live video session, a YouTube session, so you can join us and deliver on a project that you have built, something that you've learned from this course, something that you might have learned from somewhere else. But what we would love for you to do is work with us, post on, we'll basically reach out to everybody on Discord channel. Tell us what you would like to build. How would you, what is it that you are building, and what would you like to show us based on what we have taught in this course. We would love to see what you are doing, and sort of bring it to light on what you have built to whoever our audience is. Recap, we would love for you to do offer for our scholarship program. There are two scholarships that we're going to offer for our next cohort, which starts end of January. um, how do you avail the scholarship? First, scan this QR code, make a post about us on LinkedIn. See, this is the minimum we ask. We say just put our word out there so more people like you can join this course. Share this link. Use the find out information more about us, through these links. And then what you can do is, just tell us what you learned, what works for you, and then send us a response. We have about, I think, about 150 people who have sent us, filled up the form already. We would like to, like, usually we get about 500 600 people applying for our scholarship programs, and then we sort of invite two or three of them every single cohort. So if you don't get into this cohort this time, don't, no worries, you will get the opportunity to be in the next cohort from there. So you can follow along with that. There is a lot of links that we have. So if you fill up this form, just, if you even don't post but you fill up the form, what we'll try to do is we'll try to send you all the different links that we have shared, because they're scored all over the place. And the reason is, we have to try to put together this course in a way that it's not, it's basically a lot of technical stuff and non-technical stuff. So we'll basically be building more GitHubs, repos, and things like that, so that we have one centralized space. But what I ask is, reach out to us, tell us if you have a demo day, tell us, talk about our course to other people, and from there what we'll do is that we'll sort of make more data available for you all. With that, I just want to say thank you to everyone. This has been a great opportunity. Gabriela couldn't be here to say thank you to all, but she has been working behind the scenes, to make this course available for all of you. I'm not without, there's no way I'm successful without the team that sort of works behind the scenes and putting it all together for us. We have long hours, long late nights, in putting it all together. But we are very glad we took this opportunity. We'll do more of this in 2026. We would ask you to subscribe to our YouTube channel, post about it, tell more people about it, so that we can all be we can all be sharing more information. With that, thank you everyone. Thank you for being here. Thank you for being a part of this journey for us. What I like to do is I like to try to answer questions that are remaining. Um, um, Hassan, if you can help me with the questions.
Uh, yeah, Hamza. So, okay, the first question is, I'm curious what advice you have for non-engineers, product people, to be at the forefront without having to get into the depths of code. What role will PM play?
So I think you should start with N10. You definitely should start with N10. That's the first thing that I recommend people. If you don't do N10, you need to be able to do these things yourself. So start with no code tools. Start with N10. Um, Build something over there. Don't just stick to one thing and say, oh, you know what, I only want to stay at I only want to stay at I need to start Python. No, you don't need to start with Python. You need to start with n8n or langgraph or any no code tool. Then keep moving and keep building more complicated things. You don't have to build things yourself using Python to get to the bottom of it. A lot of things are now being available in no code architectures. Use those, but keep building things. We often spend time not remembering or not learning how to do those things, because we are like, if I don't know Python, I can't build an agent. Well, actually you can, and this is the time for you to build this.
Thanks, Hamza. How does MCP client server development differ from defining and developing APIs? Similar considerations.
Yeah. So they all are very similar. What they do at the end of the day is they just stick to the abstraction level. MCP sort of is like a covering on top of an API architecture. So as I said before, I did not need to learn how to connect to Airbnb. Somebody already did that. They just gave me like a connector, and all I did was that connect my architecture to that, and it sort of just works behind the scenes for me.
Thanks. We do have a question for, I think, the next bootcamp. Is there a link to that module 6 Hamza was showing? Believe that shows more detail on interfacing with ADK and A2A.
So I think what I would suggest is that just fill up the form, send us your email. I mean, we do have your email, but we don't want to spam. We'll try our best to sort of not spam anyone. Um, um, we will be sending whatever we have in a follow-up email to you all, as much as possible, so that you guys can follow through on what we did, how we have designed it, what does it entail, what we built. All of those information are available. And if you're being creative, literally just Google my name with some additional things, and you might be able to find different repos that we have already built. We're designing all of them together so that you guys don't have to go to multiple places. Trying to put it all together in one place.
Thank you. I think these are all the questions that we have.
All right. Well, awesome. Thank you, everyone. Thank you so much for your time. Thank you for being here. We will start next year with more sessions, more short sessions, so that we can get as many people in as possible. Thank you, everyone. Have a good one, everyone.